Hi everyone and welcome to this video. In this video we'll be doing a revision on the parabola. So this revision videos on graphs is a precursor to the section on the module on functions and inverses, because if you want to know about functions and inverses and their graphs, it's important that we have these basics down. Okay, so let's get into it. The parabola. Firstly, what is the general form? So the general algebraic form of a parabola is as follows. We have y is equal to ax squared plus bx plus c, where a is not equal to 0. Okay, so the reason why we put in this condition of a is not equal to 0 is simply that if a is equal to 0, then y is equal to 0 times x squared, which is just going to be 0. So it's just going to be bx plus c, which is a straight line. Simply a straight line. Okay, so a few things we need to know about the parabola. If a is greater than 0, then the parabola is smiling. Okay, what do I mean by smiling? Let me just throw an axis over here. Okay, I've got my y-axis and the x-axis. By smiling, what we mean is simply that the parabola looks like this. Okay, so it's got this upward on both sides. So we say it is smiling. If a is less than 0 or a is negative, then the parabola is frowning. Okay, so in that case we'd have something like this. Okay, and you can see there we have downward sloping on both sides, so it is frowning. So this makes sense, right? Because if you think about it, x squared will always be a positive number. So whether x is negative or x is positive, that's x squared is always positive. So if you take a and a is positive, and then you're going to multiply it by a positive number as x goes more bigger that way or bigger in the negative direction, you're just going to get higher and higher values of ax squared. Okay, and that's obviously going to overpower the x term because it's to a higher degree. Okay, so and if a is negative, then ax squared, this whole thing will be negative, right? So you're just going to, as x gets bigger this way, you're going to go bigger in the negative direction, and the same thing. Okay, so that makes sense. Let's continue. Now, whenever you plot graphs, there are a few certain points of interest. The most obvious points of interest is where do the graphs cut the axes. Okay, so the way I've drawn it here, it actually doesn't cut the axes, so I'm just going to redraw them. So we have something like this that cuts the axis, and something like this which cuts all the axes. Okay, so now for the y-intercept, what do we do here? For the y-intercept, we let x equal 0. We let x equal 0. Then what we have is that y is equal to a times 0 squared plus b times 0 plus c. And that's just going to be y equals c. So therefore, the y-intercept is 0c. So there's no work to do for the y-intercept. You just look at what that c value is, and then you know already that's where it cuts the y axis. Okay, For the x-intercept, then we let y equal 0. And then what do we have is 0 is equal to ax squared plus bx plus c. And then we solve for x. Okay, so once you have this, it's a trinomial, and then you do your standard ways of solving trinomials. You either factorize or you use the quadratic formula. Okay, now what's important to note is that sometimes the parabola doesn't cut the axis. Okay, so for example, if we look here, if we have parabola like this, so here it doesn't cut the axis, as you can see. In that case, so in this case, 0 equals ax squared plus bx plus c has no real solutions. And that makes sense because there's no x value that makes the y value 0. Okay, so graphically what we have in that case is that the parabola does not cut the axis. I'm just going to fill in these labels here. So this was the example where a is greater than naught, and this was the example where a is less than naught. Okay, now besides the intercepts, the other point of interest on a parabola are these points here. Okay, and that is, as you can see, the point where the parabola turns. Okay, so the blue are turning points. So we want to know how to work out the coordinates of these turning points. And there's more than one way to do this. Okay, so the one way is to use calculus, and in particular differentiation. Now differentiation, I'm not going to assume any knowledge of differentiation, so that's for another module. There are ways to do it without differentiation, and that's what we're going to look at now. And there's two ways of doing this. The one is to find, so method one, find the average of the roots, right? And then that the average will be the x coordinate of the turning point, and then plug in to the formula to get the y coordinate. Okay, now I'm going to do an example. Right, so that's the one way. So basically what we do is we look at the two roots, right, and then we look in the middle of the roots, so somewhere here, and that will be the x coordinate of the turning point, right, and then we just plug in the formula to get the corresponding y coordinate. Now of course this method, method one, will only work if we have roots. Okay, so I'm just going to put a little asterisk there. Will only work if the graph cuts the x-axis. Okay, obviously, because we can't, if you look at this graph over here, we can't do that method. Okay, so in that case we do have another method. Method 2 of finding the turning point is we complete the square. Complete the square. Okay, so how do we do that? If we look at this standard general form, y is equal to ax squared plus bx plus c. this is how we complete the square. Firstly, I'm going to take out the factor of a, right? So this becomes b over a times x, and this becomes c over a. Okay, then I'm going to do a little mathematical trick. Okay, what I'm going to do is I'm going to add whatever this value is here. I'm going to divide it by 2, right? So 2a, and then square it, right? And then I'm also going to subtract it, and then I've still got this c over a, and this is going to make sense in a second why I do this. I have to add and subtract the same number because I need everything to stay equal. So if I'm adding something to do my trick, which I'm going to show you now, I also have to subtract it to keep the value of the entire thing the same as it was before. Okay, so now what happens is this selection of terms here is then factorized as follows. All squared. So this bracket here is the same as this bracket here, and you can multiply that out to check, right? And then we still have these terms over here. I'm just going to write them the other way around. So plus c over a minus, and I'm going to multiply this out, b squared over 4a squared. Okay, now I'm going to take the a back inside here. So I've got a times this bracket, x plus b over 2a squared plus a times c over a is just going to give me c, and then I've got a times this whole thing here. So at the bottom I'm going to have not a squared, I'm just going to have a. Okay, and then I'm going to bracket that off. I can do that. Now look at this. Now let's just say, for example, if a is positive, then what's going to happen is that this value is constant, right? So this value, if a is positive, then the parabola is going to be upward sloping. So if we look at, and this value is always going to be positive, so if you want to know the turning point, we have to minimize this bracket, because we'll never be able to get lower than if a lower value for y, which is still here, unless this equals 0, because that's constant, this is always positive. So we make this 0 to make the entire thing as small as possible, right? So basically, if you've got a parabola here, we want the minimum y value, which is going to be at the turning point. So that means that the coordinates of the turning point is then turns out to be what makes this value 0. So it's going to be minus b to a, because if we substitute that into x, in the bracket will be 0, and this value here as it is c minus b squared over 4a, and that's the coordinates of the turning point. Now you can remember that, or you can do it from scratch like I just did when you have the example. Okay, so now that I've shown you these ways and we know what are the points of interest and how to get these, let's do an example. Okay, so now I'm going to do this example. I've got y is equal to 2x squared plus 4x minus 6. Okay, I want to plot this with all the points of interest. Okay, so I've got y and x put on my axis. Okay, first things first, the y-intercept, well, that's easy. We just look at this. The y-intercept is going to be 0 minus 6. So that's going to be, let's say, somewhere over here. So 0 minus 6. Okay. For the x-axis, the x-intercept, what do we need to do? We need to let y equal 0 and then solve for x. So, okay, over here in blue, minus 6. Now I'm going to factorize this, and if you factorize it, you should get 2x minus 2, x plus 3. Okay, so therefore 2x minus 2 is equal to 0, or x plus 3 is equal to 0. In this case, we're going to have x is equal to 1, and in this case, we're going to have x is equal to minus 3. Okay, so on our graph here, let's say x is equal to 1 is maybe about here, and let's say minus 3 is roughly about here. So this is going to be 1, 0, and that's going to be minus 3, 0. Okay, now we can put in, we can see that a is positive, right? So our parabola is going to look something like this. Okay, roughly speaking. Okay, so now we've got the one x-intercept, the other, and we've got our turning point here, which we don't know the coordinates of yet. Okay, so there's two ways we can do this, right? The one is I'm going to take the average of the two roots. So turning point is going to be the average of the two roots. So I've got minus 3 and 1. So minus 3 plus 1 over 2, which is the average of the two roots, is going to be minus 3 plus 1, that's 2 over 2, that's equal to 1. Okay, so and you can see here, 1 is exactly in the middle of, minus 1. This is minus 1. Minus 1 is in the middle of 1 and minus 3. That distance is 2, that distance is 2, right? So now we plug in minus 1 into the formula. So it's going to be 2 minus 1 squared plus 4 times minus 1 minus 6. Okay, and that's going to give me minus 8. Okay, so this point here, that is minus 8, right over there. So the turning point is minus 1, minus 8. Okay, so here we could use this method of finding the average of the two roots. Let's assume we didn't know that, and we had to use the completing the square method. Okay. If I could do the completing the square method, I'm going to have something like this. So y is equal to 2x squared plus 4x minus 6. Okay, I'm going to take out a, so I've got x squared plus 4x, oh sorry, that's going to be 2x minus 3, and then I'm going to complete the square, so I take x squared plus 2x, and then I take that value divided by 2, and I add it squared minus that squared to keep it consistent. Okay, and then this part here can be factorized, so it's going to be x plus 1 squared minus all of that that's still left, so that's minus, it's going to be minus 4, right? And then I multiply this back out, so I've got 2 x plus 1 squared minus 8, and then as we can see, the turning point is, as we have it, what's going to make that bracket 0, so it's going to be minus 1, and whatever this value is here, and minus 8, and as we can see, that is exactly what we have. Okay, alternatively, we could have just used the general form of the turning point, which we did conclude over here. Alright, so minus b over 2a, and minus b over 2a, and c minus b squared over 4a, c minus b squared over 4a, right? And that's going to be minus b, so 4 over 2 times 2, and minus 6 minus b squared, which is 4 squared, which is 16 over 4 times a, 4 times 2. And you'll get, again, of course, minus 1, minus 8 as your turning point. Okay, and that's really all there is to know about the parabola. Right, quick recap, right? If a is greater than naught, or this is the general form over here, a is not naught. If a is greater than naught, parabola is upward smiling. If it's negative naught, then it's frowning. The y-intercept is simply the value c, right? To get the x-intercepts, we let y is equal to naught and we solve the equation. We note that, like in this example here, there isn't always solutions. If there's no solutions, it means the parabola is not cutting the x-axis. To get the turning point, we can either take the average of the roots if we know them, or we do the completing the square method. Right? And that brings us to the end of this video.